Hello everyone, welcome to class 5 of manual software testing training. In this class, we are going to learn about different testing types, right? Or types of testing. So in the previous class, which is class 4 of the manual software testing training, we understood about the test levels in detail and all of different test levels. Now let us understand what are different testing types and what are some of the testing types, because all of the testing types we won't be able to cover, but if you know what exactly are testing types and the categorization of it, you will be able to understand any of the testing types for interview perspective or working in any of the project. So previously we have understood that test levels are basically 4 types of test level, right? And they are mostly related to kind of a phase that you can say. So when the development starts, you have the very unit level or small components being developed. When they are tested, it is more of a unit test or component level testing. Then when the integration happens between the units, then integration testing starts. Then when whole system gets integrated and is available as a whole to be tested, that's system test. And then when the system is available for the customer to be accepted, that's acceptance testing, right? So that was, briefly what we learned about different test levels. Okay. So now if we talk about the testing types, right? Now testing types and test levels are kind of very confusing, and many people think that the types of testing or test levels are kind of same, but they are different, right? So test levels, whatever test levels are, can be considered as a type of testing or test types, right? But all test types cannot be considered as a test level, right? Basically all the testing types can fit into one of the test levels. Okay, it can be possible, but not necessarily always. Okay, so let's understand briefly without confusing it too much or getting into too much detail. Let's see what test types are, okay, or what is the basic categorization of the test types. So when we say test types or testing types, it is basically focus on a particular test objective, okay, and there are 4 main test types, which is basically the categorization. Okay, it is mostly for the categorization perspective that you define or divide the test types into different categories. When we are testing about the functionality, okay, of the product or the software, it is categorized as functional testing. Okay, then the next categorization is about non-functional testing or non-functional quality characteristics. For example, what is the response time, how quick the software response, is it reliable, right? All of those non-functional characteristics are then another category of the testing type. Then there is another test type which is testing the structure or architecture, okay, which is mostly the white box testing, right? When we test the architecture, structural testing, the white box testing, that's another categorization or test types. And there are many testing types within each of these categories that we are discussing, okay? And then testing related to any defect fixes or software changes, for example, retesting and regression testing. So broadly, as per so this is mostly from the ISTQB syllabus. So this is broad categorization, and it holds true for the real-time projects as well, that if you are testing any product, you will mostly categorize your testing in any of these 4 levels. Basically not levels, I would say type, right? So as we have 4 test levels, we have also 4 broad categorized testing types, wherein all the different types of testing that you see, right? For example, regression testing and retesting, which is related to changes, falls into testing related to any of the changes. Non-functional testing, for example, load, stress, performance, all of that goes into non-functional. Any functionality testing goes into the functional testing, right? So let's see different test types in detail. So when we say testing of the functional testing or black box testing, right? So functional testing is also known as black box testing, because when we say black box, it is basically the user who is testing that particular application doesn't know what is implemented inside, how the code is written, how the code functions and methods are communicating within each other, right? So without knowing the knowledge, internal knowledge or internal functioning of the application when the testing is conducted, that is functional testing or black box testing. That's the type of testing. say for example, you are testing the end product, which is say for example car, right? You are driving the car, you are turning on the car, then you are putting on the gear, you are driving it, then you are putting the brake, right? So all of that, when you do not know what exactly is going on internally when you turn on the car, right? So you don't know what happens in the engine and what all combustion happens and how the car starts, right? So as an user who is testing just the driving and putting on the gears and then driving the car, you don't know what are the internal functionalities of the car, right? Or how things are implemented. So that's what the functional testing is all about. In the software context, it is kind of similar when you don't know the internal structure of the software and start testing it, right? So functional testing tests the function of the system or component, right? And if we take the same e-commerce example, it is basically you got the e-commerce website, you open it in the browser, right? And say for example, you are testing the registration functionality, right? So when you will be testing the registration functionality, you will open the register, you will click on the register button. Once you click on the register button, are you worried what has happened in the background, right? Which method has been called, which class has been called? You don't know that, right? It's kind of a black box for you. But internally something happens. There is code behind, whether it's Java or Python, whatever. It's there. There will be an API call that will be made to the server, and then you'll be getting a response that put all the details of the registration details and then submit, right? But you are not worried about any of the background things that happen. Once you click on the register, it should open the page, registration page. You put in all the details of the user, click on register, you should get successfully registered message. That's one of the test case, right? So when you are functionally just bothered and testing about just the functionality of the application, that's the functional testing or black box testing. Now, functionality is usually described in the documents, for example, software requirement specification, and if you're following Agile, it will be basically the user stories, use cases, etc. You will get all of that defined. It considers a specific behavior of the system, right? For example, registration behavior, login behavior, adding to cart, right? So functional testing is about testing the behavior of the application, and functional testing may be performed at all levels of testing, right? Now you can see the difference, right? So testing type, so this is functional testing type or black box testing. Black box testing can be present at all the test levels. It can be done at the unit level, integration testing level, system testing or acceptance testing. Basically, functional testing may be performed at any of the levels, right? Not as necessarily, but may be performed. Okay. Now, what are different, perspectives of doing functional testing, right? So requirements based and business process based. What is the difference basically? So when we say requirements based, so requirements based functional testing uses functional requirements as the basis for designing test cases, right? So whatever requirements are being provided to you as a testing team, you will just go through those documents, software requirement specification, user stories, whatever requirement documents is being provided to you, you will baseline your test cases based on those requirements. So this is requirement based, right? And then prioritization of the test cases is done based on the risk criteria of the requirements, right? So for example, there are 10 requirements mentioned. Okay. Now those 10 requirements won't be of the same priority. There will be some which will be high, there will be some which will be low, right? So there will be some, level of categorization. So based on the risk criteria defined for those user stories or requirement that you are using for designing your test cases or doing the functional testing, you will also categorize your test cases accordingly, right? So that's how you will be prioritizing your test cases. So that's one of the perspective of functional testing. Now when we talk about the business process based, so business process based perspective is about using knowledge of the business processes as the basis for designing test cases. Okay. Now when we say knowledge of business processes, it is basically, say for example, in banking, right? You are working in banking, you know all the business processes for customer onboarding. Okay. So if that knowledge is being if that knowledge is being utilized by you because you have been there in the banking industry and you know the customer onboarding process, if you utilize that process for designing the test cases and doing functional testing, it is business process based. Okay. And business processes describe the scenarios that are involved in day-to-day business. Okay. which is very common, right? So in day-to-day business, whatever customer does, right? When a customer comes to the bank, say for example, they want to apply for credit card, right? So what all process as a customer they follow, then after submission, what all processes are being followed within the bank to basically go ahead, approve the card and send the card. So all of that knowledge, if being used to do that testing, to do functional testing of that customer onboarding and the credit card overall life cycle, then that is business process based testing. And then in business process based testing, use cases are very useful because all of these business processes will be defined somewhere, right? It won't be just in somebody's mind. So if there are use cases that are there, business processes that are already defined, some are documented, and you can use that, you will be using, or basically it is more of a business process based functional testing. Now, when the functional testing is done, there will be definitely a combination of both. Okay. So requirements, yes, definitely you will be doing it, but then from the experience of the other stakeholders in the project who are knowledgeable about the business process, you will also be utilizing their knowledge to design your test cases and do functional testing. Okay, so there will be a combination of it. Now, testing of software product characteristics, the next one, right, which is non-functional characteristics, non-functional testings. Okay, when we say non-functional testing, it is basically testing the non-functional attributes. For example, reliability, efficiency, maintainability, usability, how usable the software is, how easy is it to use. It is done with the aim to find how well or fast an operation is, right? How reliable the software is, okay? How robust it is, right? And it can also be performed at all the levels, and it tests how well the system works. Okay, how well the system works. So for example, when we talk about any of the e-commerce website, right? So say for example, Amazon.com, right? When you open Amazon.com, functionality wise, you register, you log in, you add the items to cart, right? You go ahead to the checkout, and then your order is fulfilled. You get the customer support email, all the tracking process and all of that, the whole things are there, which are more of the functional aspect. Now, if say for example, you are opening Amazon.com, right? And the website opening itself takes 10 seconds to load. Then you click on register, it takes another 10 seconds, 15 seconds. Then you register after 30 seconds. So the response time is very slow, right? When you add a product to the cart, it just keeps spinning, right? It keeps loading. Will you stay on that particular website for long, right? So that is what non-functional characteristics, one of the non-functional characteristics, right? Basically how well or how quick the system responds, right? Then how reliable it is. Is it safe to put your credit card details on a particular shopping website? Are you sure that the website is not going to get hacked, right? And your credit card or your payment detail will be compromised and will be available to hackers, right? So that's another aspect, how secure the website is, okay? How fast the website is, or how fast the web application or the software is. Then many other aspects are also part of the non-functional testing. Now, some of the non-functional testing types: performance, load, stress, very common ones, right? Usability, maintainability, reliability, portability, right? So all of these are non-functional testing types which fall into the same non-functional testing category. Now, what are different types of functional testing? Okay, so we have seen about the functional testing. Now let's see the types, right? So types: unit, integration, system, acceptance, right? So these were also the levels, but are also the types, right? So all the test levels can be, types of testing. You can say, yes, all unit, integration, system and acceptance testing are types of testing as well, but not all the testing types are test levels. For example, smoke, sanity, regression, retesting, UI testing are the testing types, but they are not testing levels, right? So other way, it's not correct. So different types of functional testing, you'll see that GUI testing, white box testing, black box testing, alpha, beta, and there are many more, right? There are many more different types of functional testing available. Okay. Now, when we say testing of the software structure or architecture, which is basically structural testing or white box testing. So we have understood about the functional, which is black box testing. Now, white box testing is more of testing the structural or the internal working or the code, how the overall software modules that are being built, how the integration is happening, how the communication is happening. So it's mostly looking within the code and seeing that yes, you are getting good coverage in terms of testing. So structural testing tests the structure or system structure of the software. Okay, is it designed well, right? Is the overall structure and framework of the overall software is good, and will that be able to sustain the load and all the functional and non-functional characteristics that are required in the software. Now it is concerned about what is happening inside the box, because that's why it is white box, okay, and sometimes also known as gray box, basically, which is somewhere in between white and black box. So it refers how the structure and what happens inside the software, right? So for example, looking into the car or looking into the engine, how engine performs, right? You open the bonnet and you actually look into the engine when you are testing the car engine, right? So that's the correlation you can, and it is done with the help of code coverage tools. For example, how much code is being covered when the tests are performed, so that you know that yes, all of there is no such code which doesn't get exercised with any of the business flow, right? Or if there is any logic that is there which is unnecessarily being there in the code and it's not utilized. So all of that optimization will be possible with the white box testing, and mostly white box testing will be done by the developers, and sometimes if required you might be required to do the monitor the code coverage when you are executing your black box test cases. Along with that, the monitoring of the code coverage will be happening. So say for example, some part of the code is not being exercised, you know that yes, we need to add some test cases here so that this part of the code get exercised as well. Okay, now testing related to changes, which is also known as conformance or regression testing or retesting, right? So when testing related to any of the changes, for example, there was a defect fix, there is addition of the new functionality into the software, right? Any changes that are being done into the build or software, then there is some sort of retesting involved. Or if there is a major change or major functionality or some module that has been changed or module being added, then there might be a need to re-execute the existing test cases or the module test cases that were already working, or the modules that were already working before this change, to ensure that yes, after this change as well, after this defect fix as well, everything in the software is working as expected, right? So anything related to changes, whether it's a defect fix, implementation of the new functionality, removal of any of the existing functionality, any change that happens into the software, if after that change you are doing any of the retesting or regression testing, that is what testing related to changes is. Okay, and testing related to changes have two types, so which is retesting, which is confirmation testing as well. Retesting and confirmation testing are same, and regression testing. Okay, now when we say conformance testing or retesting, so conformance testing or retesting comes in picture when a particular test case fails. Say for example, you are doing the test execution, okay, and there was a test which has failed. So when the test will fail, you will log a defect for that, and if the defect is found to be valid, developer will go ahead and see what was the root cause and they'll fix it. Okay, once they'll fix it, that means they have done some changes in the code, right, to fix it. Once they have done those changes to fix the defect, they'll retest themselves, right, and then they'll package a new build and deploy a new build. Okay, now once they have deployed the new build, they'll move that defect to you to again retest. Okay, and when you re-execute those same steps to re-execute the test case for that defect, that is what retesting or confirmation testing is. Basically, in the first time that test case failed, now after defect has been fixed, new build has been has arrived by the developer, that has been deployed, and you are re-executing or basically retesting or following the same steps, same test cases again, to see that yes, previously it was not working, now it is working after the fix. So that's what confirmation testing or retesting is. Now when we talk about regression testing, okay, so regression testing, if a defect has been fixed, right, it might have affected other areas of the code as well. For example, if there is a login functionality, okay, and the login functionality was working absolutely fine except the login using the social media account Twitter. Okay, so there is a login using the email and password, and then you can also log in using Facebook, Google, and Twitter. Say for example, assume that okay, our website supports these 4 types of login. Now all of the login functionality or the test cases passed except logging in using the Twitter account. Okay, just as an assumption. So when this login module or this defect will go back for fixing, it might impact other login modules as well, right? Because previously Facebook, Google, and everything else else was working. Now, because this Twitter login is not working and the login module is as a whole, so once the defect will be fixed for Twitter, it might impact other login areas as well, right? So unexpected side effects could be possible, right? Because the whole login module contains the overall code for every login functionality or every login possibility. So in that sort of case, unexpected side effect might happen, right? If there is something related within the code and there is a code that has been touched or updated that might have some relation with other areas of the module or the code. If that's the case, then the regression testing is required to verify that any modifications in the software have not caused unintended side effects into the software. For example, Twitter login failed, right? And the defect fix has been deployed. Now you will retest the defect, okay? You will retest that yes, Twitter login works after the fix. But then the purpose of regression testing is to also ensure that apart from this Twitter login, this change or this defect fix hasn't broken any of the other login functionality. For example, email login functionality is working fine, Facebook, Google, and Twitter, all of them should be working fine. So that's where this regression testing comes in picture. And if we consider this module as part of this defect fix, all 4 scenarios or related test cases with all the login related test cases need to be re-executed, right? Or regression tested. This whole module, login module, needs to be regression tested. Okay. So whatever fix will happen, that is retesting. But along with that, if there is any unintended side effect, there will be more test cases around the surrounding area of the changes that will be done. And that is what regression testing is. Okay. So the third point, you can see regression tests are executed whenever the software changes due to defect fix or addition of the new functionality, right? So if we say this was the defect fix, now tomorrow, say for example, apart from Twitter, there is another social media account or another login possibility that will be added. Okay, that's addition of the new functionality. So that can also impact the whole login module, right? So that will again require regression testing of the related test cases around login module to be re-executed, and that's another area wherein you will be doing regression testing. So any defect fix could trigger it, or any addition of the new functionality could trigger regression testing. Now regression testing can be, partial, full regression. So that depends on the level of change. Say for example, there is very massive overhauling of the overall software architecture. You will obviously be doing full regression, which is basically executing all the related module test cases or all the test cases that are related or that are considered regression test cases for the overall application, right? And all the test cases in regression test suites are executed every time the new software version is available. So regression test suite is an ideal candidate for automation. Okay. So if somebody asks, what's the ideal candidate? So basically regression test cases are the first sort of test cases that you should be, apart from the build verification, you should be targeting regression test case first candidates to be automated. Okay. Now why? Because with every software build, there will be a set of regression test cases that needs to be executed to ensure that whatever was working till now is actually working. Okay. So that's what regression testing is. Now impact analysis and regression testing. What is the purpose or the purpose of the impact analysis with the regression? So usually maintenance testing consists of 2 parts. Okay. When we talk about maintenance testing any changes, and regression testing to show that any changes done in software does not affect rest of the software. Okay. When we say impact analysis is the main activity in maintenance testing. All right. So impact analysis is sort of, you can say, analyzing the overall changes that are being done, and it is done usually with the stakeholders to decide which part of the software might have been unintentionally affected. All right. So in that particular case, regression testing will be required. For example, when we say, maintenance testing. Okay. So maintenance testing will trigger basically if, say, for example, there are any changes being triggered into the software or any changes being done. All right. So that will trigger regression testing. Regression testing how will you identify what needs to be regression tested? You need to do impact analysis first, right? What has changed? Which modules have changed? Okay. Where the code change has been made? Will this code change? Is this code change impacting, 5 different modules or for 50 different modules? Right. So this is what is impact analysis. Okay. So seeing what exactly has been impacted based on the change or addition of the new functionality or fixing the defect. Now risk analysis is another thing which helps to decide where to focus regression testing. Okay, now based on risk. So for example, there are 10 different features and 5 of those are very highly used, right? Everyday end users or customers use those features, but rest 5 are occasionally used, right? So that gives you a fair bit of idea that definitely for these 5 highly used features, we are going to definitely plan, full regression because they are impacted, right? So risk analysis is another important criteria to identify or what will be the focus of the regression testing whenever any changes happen. Okay, so when we say impact analysis, it is very key part which is done with the stakeholders and people within the business. So all of the stakeholders to see what changes have been done or made and what needs to be done in order to do the regression testing, right? Or which areas we need to focus more for doing the regression testing. Okay, so this is what impact analysis is, and it is a must sort of thing before you go ahead and plan your regression testing, because that's how you will be able to identify how many regression test cases, how many modules and how many test cases, and what will be the priority of those test cases based on the risk analysis. Okay, now what is static testing? So if we talk about static testing, so testing of a component or system, right? So testing of a component or system at a specific implementation level without executing the code, right? So this is another type of testing, which is static testing. So as the name suggests, when you do not execute the code, right? When you do not launch the application at all, you just have the documentation, you just go through the code manually, right? You analyze whether the code has been written properly, all the coding principles have been followed, or when you have the user stories, when you have the requirements, going through those requirement documents and then making sure that everything that needs to be articulated is there. So when any of this walkthrough, technical reviews, inspection, peer review happens, that is what static testing is all about, right? During static testing, software products are examined manually with some tool but no execution. Okay, so test execution is not being done. You do not launch the application. For example, there is an e-commerce application, right, being built. So before that, you will be having the requirement, right? So requirement will say, okay, we need a login functionality. Has the login functionality requirement being articulated properly? Has the registration functionality being articulated properly? Are all the user stories complete with the proper acceptance criteria? Are all the scenarios being covered? Right? So all of that reading and then understanding and then discussing within the team is static testing. Okay, static testing helps to verify the software deliverables for which dynamic testing techniques cannot be applied, right? So for example, for any of the documentation, user stories, you cannot do dynamic testing, right? It's just a documentation. So static testing is done to ensure that there are no gaps, first thing, right, in those requirements in any of the document, as well as all the relevant information is present there. There is nothing missing. All right. For example, the test plan, requirement document, design document, everything is there in place. Okay. So that's what static testing is. Now, if we talk about more, you'll see that it's a powerful way to improve quality because you do it upfront, right? So as soon as the requirements are available, you go through the requirement and then you see what all details are there present in the requirement, and then you go ahead and start thinking about how you are going to develop it, test it. Developer will understand how they are going to develop it. You as a testing team will start understanding how you are going to test it, what will be the scenarios. You will also understand if there are any gaps, right? So, and you will provide the feedback that we missed something here, right? Or you will clarify, and maybe there are gaps, they'll be added. So that will ensure that those mistakes that are there in the document or in the requirement that don't flow to the design and then develop, and then they are identified later in the testing phase. So that's where it is a powerful way to improve the quality of the software, right? Then it is not a replacement of dynamic testing. Okay, make sure that both of them have their importance. So static testing and dynamic both have their importance, and static testing is in addition to dynamic testing, right? It's not a replacement at all. Now, what is the difference between static testing and dynamic testing? So if we talk about static testing, it examines the software deliverable without execution. Dynamic testing is with execution. You actually launch the application. Say for example, e-commerce application, you will open the browser, you will launch the website, you will click on the register button, you will put the details, submit it. So you will follow all of that on the real software. Static testing, you will just go through the requirement documentation and understand what all details are being provided, how you are going to test it. Are there any gaps? Is all the information provided or not? Right. And static testing finds the cause of the failure. Okay. And dynamic testing finds the software failure. Static testing technique is known as verification. Right. And dynamic testing is validation. So if we talk about the V model, which is in here, so you will see static testing is in the side wherein you have the requirement, then system requirement, design, detailed design. Right. So all of these are documentation. Right. All of these are documents. So you have the requirement document, software requirement document, or the user stories in Agile, right, which then converts to system requirement, then design, global design, high level design, and low level design. So these documents, when you go through, read through, and see that yes, all the relevant information is there, nothing is missing. If there are any gaps, you provide all of those details. That is what all static testing. So this all phase basically static testing. Now during the implementation, which is coding phase, peer reviews happen. So developers do the code, write the code, and they sit together and see each other's code basically, and then analyze that everything is as per the standards. So this is what static testing is. As soon as the software is ready, build is deployed, and you actually start using tools and doing the execution, or launching the application and doing the execution, that's where the dynamic testing starts, right? So in the V model, one side you will have the verification, one side you will have the validation, right? So this side is validation, and this side here, the static testing side is verify. Okay, so that's pretty much all about this particular session or the class for the types of testing, right? And in the next class, I'll be talking about the test development process and test design technique. Very important section and class. There'll be a couple of classes on this, so stay tuned, and I hope this particular class was helpful. So please share this particular class, the whole series, with any of your colleagues, any of your college mates, and distribute this free knowledge. And I hope that all of you basically start your career soon with all of this knowledge that you are gaining, and be a excellent software test professional in the industry very soon. So that's all for this tutorial. Thank you very much for watching.